Hi, guys. Um, we're going to continue with chapter 7 today, section 7 2, the next section in chapter 7. If you have not been watching the videos, please go back and watch 7 1 first. Although they're not, you don't have to, I guess you don't have to watch 7 1 first. But you definitely need to go back and watch it as well. So today we're going to talk about 7-2, which is angles and the unit circle. We're going to talk about what it means to draw angles on the XY axis coordinate grid, things like that. So I'll wait just another second. As of today, things are changing. If you didn't get the email from, if your parents didn't see the email from the high school or from the district, things are going to start being graded. So just so you know, please continue sending me emails with questions that you guys have, and hopefully these work out for everybody. If the videos are not working, if you need some more support from me, and you're having trouble with the homework or whatever, make sure you're letting me know that. I need to know. Email is the only thing we've got right now, so let me know. All right, so 7-2, which is angles and their measures. So if this is my XY, if this is my XY axis, this is X, positive X, this is Y, positive Y, so negative X, negative Y. An angle in standard position has its initial side. So I'm going to draw that right here. Initial side stuck. Think of it, it's fixed. It's a fixed position. Think of it as being glued to the x-axis, the positive x-axis. That initial side is stuck there, does not move. Think of the other side of the angle swinging open like a spinner. So the vertex would be sitting here at the origin, and if I opened the an angle, say to 60 degrees or 100 degrees or whatever, that part is the part that opens to create the angle. So that's called the terminal side. The terminal side is the side that moves to create the angle. So this is called the terminal side. So that's an angle in standard position with the initial side glued to the positive x-axis, and the terminal side is the one that opens to create the angle. So coterminal, erase these two. Coterminal, this section is full of a bunch of vocabulary that we need to cover about angles and things like that. So coterminal means two angles that have the same terminal side. So this is a positive angle opening in this direction. An example of a coterminal angle would be an angle that opens in the other direction and lands in the same spot. So if I open the angle this way, right, from the initial side, it swings open, around, and stops in the same position. This would be considered a negative angle. So positive always opens through the first quadrant. So it goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. If it went all the way around, it would create 360 degrees and land back where it started. So a positive angle opens in this direction. A negative angle opens in the other direction, so backwards. Okay. If it opens down, that's negative. And then angles can open. My dogs are being loud. Sorry. Angles can open more than 360 degrees. So think of it like swinging around a bunch of times and then stopping. So if it went around one full time and then stopped here, that would be an angle that would be bigger than 360 degrees. So that's the first thing you're going to be doing. You're going to be looking for some coterminal angles. They're going to give you an angle, and you're going to come up with some coterminal angles for that. So I'm going to erase this and draw one. And then we'll come up with some coterminal angles for that. So here's my X. Here's my Y. If this angle opens to right there, they're going to have a little piece in here labeled for you. This is what's called a reference angle. A reference angle is an angle formed between the terminal side and the nearest x-axis. So formed between the terminal side and the nearest x-axis. So this little 35 degrees right here is our reference angle. So what we need to come up with is three things. A positive angle that opens and stops right there, a negative angle that opens and stops right there, and then an angle that goes larger than 360 degrees. So at least one full cycle around and then stops in this position right here. So I'm going to erase this definition of a reference angle. This is, again, my notes are posted on Canvas and of everything I'm going to talk about today. And this is in the notes. So don't feel like you have to get it written down really fast if you don't have it already written. Okay, so a positive angle, a negative angle, and greater than 360 degrees. So for the positive angle, it's opening from here to there. So if the angle is opened from the positive x-axis to the negative x-axis, creating that full line, that would be 180 degrees, right? 180 degrees is one straight line. So this additional 35 degrees means our positive angle would be 180 plus 35, or 215. You see that? Okay. The green isn't very bright. I know. It does not match the wall color. All right. So a negative angle opens in the other direction, this way. So you might think of just all the way would be 180, subtracting the 35 would be, so subtract 180 minus 35, or you can think of it as a negative 180 plus 35. Either way, you end up with negative 145. I'm going to erase that part. So what I did was a negative 180 plus 35, or 180 minus 35, and then change it to it. Does that make sense? This would be 145, but since it's a negative angle, you have to label it as a negative 145, which is why this way of calculating it kind of makes a little more sense. All right, there is that. And then greater than 360 just means that it went around one full and then stop there, or two full and then stop there, or three, and then you could do as many as you wanted, as many. So if you just did the one full, which is 360 degrees, plus the 215, which is the positive 360 degrees, plus the 215, which is the positive, that would be the easiest, the first. You could also do 720, which would be two full revolutions plus the 215. You could do three full revolutions plus the 215, infinitely many answers to that one. So greater than 360, 360 plus 215 is 575. Okay, so that's how that works. Let's do one more like this one. Okay. So in this example, they give it to us in words and not necessarily a picture. So if we're told that our reference angle is 70 degrees and it's in quadrant 4, that's how the book represents quadrant 4. And they might even write it out, quadrant 4, right? That means the fourth quadrant. So the quadrants are 1, 2, 3, 4, like so, right? Erase. So if I draw a picture of this, similar to the picture we just did a second ago, I'm talking about an angle in the fourth quadrant with, so here's my initial side sitting on the positive x-axis, and my terminal side sits in the fourth quadrant with a 70-degree reference angle. So again, we're going to do three things. What would the positive angle look like? What would the negative angle look like? And then what would a greater than 360 degrees look like? Okay, so that end doesn't look very nice. Okay, so positive means it went this way, right? So you could think about that being 70 and this being 20 and go 270 plus 20, or you could do 360 minus 70. If I did a full rotation, which is 360 minus 70, right? Or I could do 270, which would be right here, plus the 20-degree angle that's in right there. Up to you how you do that. Okay, so this one would be the positive angle would be 290 degrees. Either way, however you look at it. So the negative angle, when it's in the fourth quadrant, is super easy. It's just the 70 degrees. And of course, we label it with a negative. So negative 70 degrees. And then our greater than 360, again, one full revolution, which is 360, plus the 290, which is the positive angle, is the easiest, again, to come up with. So 650. Okay. Erase that. Okay, so let's just talk about a couple of things that I probably should have covered before we talked about that. So so if the initial side is here, right? If I open straight up, that would be 90 degrees. Make sense? If I open out to the left, the x-axis, that would be 180 degrees. And if I open straight down, that would be 270. If I opened all the way around, 360. So think if that's not something that you intuitively knew about, that's one of the things we talked about in the last example. So each of the quadrants is a 90-degree angle. Okay, so the next thing we're going to talk about is converting radians to degrees and degrees to radians. So what is a radian anyway? What if we're going to convert from radians to degrees or from degrees to radians, it would be helpful if you knew what it was, right? So let's just talk about, again, a circle that's been placed on the XY axis, like so. Do my best to draw kind of a circle that doesn't look awful. Oh, well, that's not it, is it? Okay. Okay. That's a little bit better. Okay, so we talked about the angles. This would be 90 degrees up here. Let's put it in red. 90 degrees would be here. 180 would be there. 270 would be there. And 0 if it doesn't go anywhere. 360 if it goes all the way around, right? Okay, so think of this circle for just a second as it's a normal circle, and its radius, which would be this distance here, from the center of the circle to the outside of the circle, that's the radius, right? Let's say that that's 1 unit. This 1 unit is why it's called the unit circle. So that radius right there, that distance. So if I had a little piece of string and I measured that little radius and I tacked it onto the circle itself, how many times would that little piece of string go around the circle? What do you think? Well, that little piece of string that I measured here, and if I measured it around the outside of the circle, it would go around the circle 6.28 whatever times. The circumference of the circle is 2 pi times the radius, right? Whatever the radius is. That's where the idea of radians comes in. It comes in by measuring a portion of the circle using this idea of it being 2 pi. And in this case, our radius is 1 unit, so our circumference is 2 pi. So if I cut a piece of the pie out, like just this corner up here, right? If I took just this corner right there, that angle, how much of the circle is that? Well, the full circle is 2 pi. That piece right there, 90 degrees, would be pi over 2, or half of a pi. Half pi, not of a pie. It sounds like I'm talking about pie you could eat. So think of it this way, that the half circle, since the full circle is 2 pi, half of that circle is just pi. A fourth of the circle, or 90 degrees, would be half. 1 half, 2 halves makes 1 whole. 3 halves is 270. So 1 full circle, the circumference of that circle would be 2 pi. If we think in terms of that and say how much of the circle do we have, 90 degrees, which would be just this corner right here, is pi over 2. 1 half of the circle, so a half circle, right, is 180 degrees, and so on. Okay, so here I have a picture. Where did it go? Here it is. Okay, so think of it like this. Here's our circle, 1 full circle, and half of that circle is pi, or 180 degrees. So how many 60-degree angles could go in here? 60 degrees is pi over 3 because 60 degrees sits right there, right? And I can get 1, 2, 3 of them between 0 and 180. Let me show you that up here. So if I'm talking about cutting the top half of the circle into 60-degree pieces, there's 1 there, 1, 2, 3, right? So 60 degrees is the same as pi over 3. You can also think of it as like 60 is a third of 180. And then 45 degrees, which goes right here, right? It cuts that 90-degree angle in half. So there's 1, 2, 3, 4 of them. So 45 is the same as pi over 4. 180, right? Divided by 4. And then 30 degrees is the same as pi over 6. Okay, so now we're going to convert from radians to degrees, given any amount. Erase. Okay, so if I was going to convert pi over 10, which is a radian measure, to degrees, I would multiply by a fraction that would have degrees on the top and radians on the bottom. Now, if I need to get from radians to degrees, I want to cancel the radians and end up with degrees. So the degrees goes on the top and the radians goes on the bottom. So what do we know is equivalent, an equivalent fraction, right? Where degrees and radians. So for example, if I was going to convert to feet from inches, right, I would divide by 12. Makes sense? If I was going to convert from feet to inches, I would multiply by 12. Now, we do that kind of instinctually. We don't think about writing it as a fraction like that. But 12 inches and 1 foot are equivalent measurements, just written in two different units. So that's the same thing we're doing here. What are two equivalent measurements? Degrees, 180, and radians, pi. Now, I could use 360 and 2 pi, right? 360 is a degree measurement equivalent to 2 pi radians. Now, this is the same as using pi over 180. They're equivalent values, 360 and 2 pi, 180 and pi. This is the simpler fraction, so let's use that one. Okay, so I'm going to take off the degrees and radians because that's a little cumbersome. Okay, so then the pi's cancel, right? A pi on the top, a pi on the bottom. And then you're just left with 180 divided by 10, or 18 degrees. So what about 7 pi over 9? Again, we're going to multiply by 180 over pi. And again, the pi's cancel, right? So then you have a calculation of 7 times 180 divided by 9, and you get 140. So what if it's something like 2 pi over 3? You can continue using the conversion ratio of pi over 180, and you get 2 times 180 divided by 3, which is 120. Or you can think of 2 pi over 3 as what we talked about a minute ago. Now, if that was very confusing to you and this doesn't make any sense, then feel free to keep doing it that way. But pi over 3 is the same as 60 degrees. So 2 times 60 is 120. That's a little bit of a shortcut, so you're welcome to do that. You can see it right here, 180 divided by 3. That's where the 60 comes in. And so 2 times 60 is 120. I'm going to erase this. I have a couple more examples like this. We're going to go ahead and draw the next couple of angles along with figuring out their degree measurement. So if I'm given negative 5 pi over 6, and I do the multiply by 180 over pi, the pi's cancel, and I have negative 5 times 180 divided by 6, which is negative 150. If you do the shortcut, pi over 6 is the same as 30, and you end up with the same answer, negative 150. So where does that angle land? What quadrant would it be in? So a negative 150 degrees is going to open in this direction, right? And open about to right there. So it would land in, quadrant 3. Erase. Just that part, I'll leave it up there. And then the next one is, what if it's bigger than 360? 9 halves is 4.5 revolutions. So this is bigger than 360. Again, we can multiply by 180 over pi. The pi's cancel. 9 times 180 divided by 2 is 810. Or if you did the shortcut, pi over 2 is the same as 90 degrees, and you get the same 810. So I know that 1 full revolution is 360. That means 2 times around would be 720. So this angle, which starts, we always start right there, right, is going to open once, twice, and stop right there. Now, if it asks you where that lands, that doesn't land in a quadrant. That lands on the positive y-axis. So keep that in mind. When they land on an axis, you'll name it that way, as opposed to naming it in a quadrant. Okay, so now we need to go the other direction. We need to be able to convert from degrees to radians. So I'll erase all this. So if we have 75 degrees and we're converting to radians, again, we want a conversion ratio with, in this case, radians on the top and degrees on the bottom. So we're going to use the same ratio, 180 and pi, and this time the pi would be on the top. And then that's just a calculation. You're just going to go 75 pi over 180. If it was something that could simplify, like this one can technically simplify. I could write that as 5 pi over 12 if I divided each of the 75 and 180 by 15. That's how that fraction would simplify. So you could leave it 5 pi over 12, or you could write it in decimal form. It would be 1.309 radians. And that's just a calculation. If you have a scientific calculator like mine, you should have a pi button on it somewhere. If you don't, you would have a pi button on your phone calculator. If you turn it sideways, let me clear out what's in there. If you turn it sideways, my iPhone has a pi right there. So I could just do, you have to type in as 75 times pi divide by 180 to get the answer. But that's how it would work. Okay, so 112 times pi over 180. Again, just to multiply 112 times pi. To multiply 112 times pi, divide by the 180, and you should get 1.955 radians. And then I talked a little bit about this on the first one. What if it's an angle measurement that can simplify? It's one of, we can, the same thing, we're going to multiply by, this is a negative angle and it's one I'm going to show you that you can just simplify it. So if I'm multiplying by pi over 180, 210 pi and 180, both of those can simplify by dividing by 30. 3 goes into 21, 3 goes into 18. I could leave this as negative 7 pi over 6. Or I could type it into my calculator and come up with a decimal. I could also think of it in a shortcut way as 210 is the same as, of our 3 that we talked about, 60, 45, 90, or I guess there's 4. 90, which is pi over 2. 60, which is pi over 3, 45, which is pi over 4, 30, which is pi over 6. 30 goes into, we talked about it over here, 30 goes into 210. 30 is the same as 7, or I'm sorry, 210 is the same as 7 times 30. Let me get that out right. So I could rewrite this as negative 7, and then 30 is pi over 6. So that's a different way to think about it. As you get more comfortable with those ones we talked about, this would be a kind of a shortcut, but not necessary. And again, I think your assignment is on Pearson Online, and I think it will accept both the fraction version and the decimal, but you can definitely put in the decimal. All right. I have one more thing, which is arc length. So I'm going to erase this. So arc length, what we're referring to in a circle, this is probably not a very good circle. Here is what's called an arc. And the arc length, which would be this piece here, is what we're looking for. This in here is called the internal angle. I'm going to use a little theta symbol to represent the angle. And then the radius of this, you're going to multiply the radian measure of the angle times the radius of the circle. So for example, if I have an angle of pi over 3 and a radius of 200 kilometers, I just need to multiply those two together. The arc length is pi over 3 times 200, or 209.4. And then make sure that you're labeling it with the correct units. If they give you units on the radius, that would be the same units for the arc length. So that's really all there is to it. It does get a little confusing if they don't give you the angle in radian measure. So I'll give you one of those examples as well. So what if they give you the angle in, erase this. What if they give you the angle in degrees instead of in radians? So what if they give you an angle, oops. What if they give you an angle of 108 degrees? And then they give you a radius of 18 feet. Well, we're going to multiply the angle times the radius, but the angle has to be in radians. So we first have to take our 108 degrees and multiply by pi over 180. And that decimal the calculator is going to give me looks like this, right? Now, what I want you to be careful of is, let's say I did that with my iPhone, my phone calculator, because on a scientific calculator, it's much easier. So what if I did it on my phone calculator? What if I took my 108 times pi, divide by 180, and that decimal 1.8849, I rounded it to 1.885. Now I know to find the arc length, that I'm just going to multiply this times 18, right? So now I have that decimal in my calculator. The next step would just be to multiply by 18. Yeah? 33.9. So we get, yeah? 33.9. So we get 33.9, and then again, we label it with the same units as the radius. Okay, so your assignment to go with this video is the online, Pearson Online 7-2 practice assignment. So, all right, let me know if you guys have any questions.